Completing the square is a process to take a quadratic expression in the form of x squared plus bx plus c, where b and c will be numbers, and create an equivalent expression in the form of the quantity x plus m squared plus n, where both m and n will also be numbers. This form should look familiar. In previous lessons, we referred to this in a function as vertex form. Let's go back to this phrase, completing the square. If you're trying to complete something, that means that something is missing. If we take a look at our starting expression, x squared plus bx plus c, we could actually see the square in a model. If we zoom into this graphic, we can see that we have x squared plus bx shown in this model. X squared is a square with side lengths of x. X times x creates a square, x squared. Plus bx is another rectangle with the length of b and the other length of x, so the area of this rectangle is bx. If we wanted to put this into a square formation, what we could do is we could actually take the b rectangle, slice it down the middle in half. Now the length of half of this rectangle is b over 2, or half of b. We could then take this one piece, rotate it, and put it down here, and we get this graphic at the end. Now this is almost like a square, except for we are missing this final little bit right here to complete the square. If our smaller rectangles are both b over 2 and b over 2, then we know that the area of this small missing square is b over 2 times b over 2, or b over 2 squared. So that is the missing part to complete the square. If we know the coefficient of x value, we can take the value of the coefficient of x and use that to give us the information we need to complete the square. The quadratic expression x squared plus bx plus c can be rewritten into an equivalent expression of the form x plus m squared plus n if m is equal to half of the coefficient of x and n is equal to the numeric term of the original expression minus that missing part of the square. In our example, the coefficient of x is a positive 12. So in the equivalent expression, we have the square binomial x plus 6 squared, because m is equal to 12 divided by 2, and that is 6. N is equal to the numeric term of our original, 20, minus the missing part of our square, which is 12 divided by 2, which is 6 squared equals 36. 20 minus 36 equals negative 16. So the expression x squared plus 12x plus 20 is equivalent to the expression x plus 6 squared minus 16. Let's check for understanding. What is the missing part needed to complete the square of the expression x squared plus 10x minus 8? How do you know? Use this information, remembering that b represents the value of the coefficient of x. A 100, B 25, C 16. Blank is the missing part needed to complete the square because B 25 is the missing part needed to complete the square because b, the coefficient of x, equals 10, and half of 10 is 5, and 5 squared is 25. You take the coefficient of x, divide it by 2, and then square it.